parts of 2.5. 2.5 is actually optional, the whole section. There's no problem that A/B testing would need that for. The two diagrams are helpful, so we did those. We're not doing the second part of 2.5. It's not on A/B test. Right, so we're getting into. You kind of see why we play Deal or No Deal. Hopefully by the end of this. How that works, but it was just fun. So let's start going through. We flip a coin 3 times. So the sample space, which is a list of all the possible outcomes. All possible outcomes. So you would go through, if you wanted to make a tree, you could, like HT, and then like HT, and then keep doing that. I think with like flipping 3 coins, you don't necessarily need to. Kind of just list it. But maybe it's easier because it's hard to keep track of what you have. I'm just listing all the combinations. Again, if you get stuck and you want to like really make sure you got it, you just start doing this. One more branch, you can just them all out. How many outcomes are there? 8. How does that happen? That's not the last 8. Why is it 8? Why are they possible? Because what? Okay, be more specific about that. With the fair coin 3 times. So what's the? How many outcomes are there on the first time? First flip. 2, second flip, 2, third flip, 2. Multiply those together. 2 times 2 times 2. There's 8 possible. So it's 2 to the third, really. Because there's 2 outcomes, 3 times, there's 8. Possibility of any outcome is there. Wait. This is just like making sure you know what these means. X equals 0 would be, so we're looking at the x's number of heads. We know 0 heads. Like 0 heads. What's the probability? I got 0 heads out of all of those. How many had 0 heads? 1. Just the tails, right? Out of 8. X equals 1 would be 1 head. 2 heads. 3 heads. How many times do we get heads once? 3. Sometimes we get heads twice. Same question as tails once, which you basically just answered for the opposite. Right? Still 3 A's. And then at 3 times is the same probability as at 0 times. So you won't really ever do this. This is kind of just to summarize it to get to this. This is kind of what you usually see on probability table. So X is probability of heads, probability of X. So what's the probability we get 0 heads? You just fill it in the probability for each possible outcomes. You might be asked to make a graph of it. Like 0, 1, 2, 3 on the bottom. On the side, I'll put the probabilities. So 2 A's, you can put 1/4 there. and these are just like, do you know how to read this table? So x equals 2, it's fairly straightforward. You just read the probability x is 2. X is greater than or equal to, so just make sure you realize the or equal to, so this would be 2 or bigger. So technically 3/8 plus 1/8. Make sure you have those two things. If you want to say 4/8, that's cool. If you want to say 1/2, that's fine. Well, then x is less than 2, would you include 2? This is the part where you tell me you would not include 2. So you just do 1, 0. Again, 1/8 plus 4/8, or if you're really fancy. Question on that page, I think it's pretty straightforward. Alright, this page. So when you do these probability distributions, like a table we just did, these are the 2 rules. I think they're kind of common sense. Every probability is a number between 0 and 1, and then they have to add up to 1 and 1. Those 2 arrows I wrote, that really help everything. Alright, so let's do a probability distribution for this situation right here. All the letters of the alphabet in the hat. You choose a consonant, I give you $1. Vowel, I give you $5. Y is not a vowel in this situation. X is the random variable, create the distribution. So, I want to make this guy. So the outcomes go on top. Probabilities go on the bottom. So there are 2 possible outcomes. Which are 1 and 5. You might win 1, you might win 5. Those are your 2 options. What's the probability you win 1? That's constant. So which many vowels? How many vowels are there? 5. Probability of getting a vowel is 5 out of 1. Probability of getting a constant is 21 out of 20. If you gave me this table, I would say this problem might be like 3 points. You get 2 right now. I think you're missing. Yeah, if I just give you this, you can't see anything else. What are we even talking about? I have no idea what's happening. I don't know. Same as anything else. Put context, label it, title it. So you need to say like X equals money, like money paid, or money earned, or amount you win, or something about, so I know what the heck this table is. Area under density curve. So if I add up all the problem density curves, like one of these guys, what's the probability that that represents? What are the sum of the probabilities then? So what's the area under this curve? Okay. Now this is the part that I think is much more interesting. X is, whatever the outcome is. E of X is the expected value. So that might sound familiar from probability of each of those? 1/3. Like they're all, it's all equal, right? So they're 1/3 each. So the way you would find the expected value is you multiply the outcome times the probability plus multiply the outcome times the next probability plus multiply the next outcome times the next probability. This expected value would be like 1/3 times 0 plus 1/3 times 5 plus 1/3 times 1,000,000. And if you notice when the probabilities are all the same, that's just taking the average. So if I just did 0 plus 5 plus 1,000,000, if I multiply by 1/3, which is all that's doing, we just find the average. It matters that the probabilities are different, which they similar. So here's the average. So if I calculate that, $1,005,000 divided by 3, 333,335. So that'd be like their fair offer. We were just doing this like shortcutting on Friday because it's an average so simply. And then they'd offer you like 200 or something. You might take it with one of them. Right? Questions on that? Anywhere up there? Right, turn page. So I don't know how many will use this actually, because I think it's. How do I know the formula? So if you have a bunch of different x's, this is like a general formula, so it's x1, x2, x3. These are different outcomes. That might be $0, $5, $1,000,000. This is the probability of each outcome. So the first outcome has the probability of one, the second outcome has the probability of two, etc. The way you find the expected value is x1 times p1 plus x2 times p2 plus all the way to xn times p. Not a lot of people think about that formula that way. It's kind of Compact formula, I'm not even gonna worry about it. It's got like summations in it, and done summations, just yeah. Let's go through this example. Northwestern University. So we got A's, B's, C's, D's, and F's. So A's are 4, B's are 3, C's are 2, D's are 1, and F's are 0. Here's GPA. What are the possible outcomes? Those aren't numbers. I can't do like 0.2 times A. So it's 4, 3, 2, 1, 3. It's just like converting, just like your guys' grade. A is 4, right? So those are the outcomes. I don't know what the probability of each outcome. So the probability of a 4, which is an A, is 0.26. So go ahead and fill the rest of that out. Let's just put in the probability. And then let's look at the question. So say we're probability. So 3 or more. Just add up these two probabilities there. Show word this, but number 2 is going backwards. Try 2 and 3. Number 2, you have to write like the probability question, which I think is harder. Try 3 and then we'll look at it. I think I was going too fast. Am I good? Got a grade worse than C, so that's worse than a 2. So I would want the probability x is less than 2. Or you could do the probability x is less than or equal to 1. But you want it worse than a C. So this is say worse than a C, this is say equal or less. That would just be 0.1 plus 0.12. So 0.12. I'm more curious about, I think most of my answer. I'm more curious about that. I think I wrote that right. That's not bad. Alright, part 3, compute the mean of the random variable. So multiply those two things together, plus 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 multiply those two things together. So you will sometimes be asked to like show your work. So you would do this. But in a second I'm going to show you how to do the calculator as well in a situation where you don't have to show your work. You wouldn't have to write all that out. But sometimes you do. So I'm going to show you both. That's the expected value, so that's E of X. Or it's the mean, but the same thing. So you can type that in. I'd rather just show you how to do the calculator. Get out your 84s if you don't have them out. Your TI 84. So go to stat, edit, outcomes go in L1, and your probabilities go in L2. Stat, edit. Remember, you can clear the list by like going to the top where it says L1. When hit delete, that destroys the whole thing. You can hit clear and then enter, and it'll clear the list for you. Go up to L2, hit clear and enter. Clear the list for you. It doesn't matter which order you go in, but you have to go in the same order for both rows. Like you could do that way for both, that way for both. Just don't do. Need to go back. why I wanted to go back to that, because a lot of people mess up with this question. How many variables are in this problem? It's tempting to say two. I think you're all going to say it. I think it's tempting to say two because you see two rows of data, but there's only one. This is the student grades. This is just the probability of getting that student grade. So the entire thing is about a student grade. There's one variable known as student grade. So hit stat, and then calc. And this is where people first go wrong. It is not two variable stats. You see two rows, so you're tempted to think that, but it's, the whole thing's about student grades. So top row's grades, which the bottom row is not a new variable, it's just the probability of grades. So it is one variable stats. But you have information about that variable in two lists. So L1 is the outcomes, and then the frequency list, I want that to be L2. Because that's the list where I put how often things happen, frequency is all that. I know some of you have a different list, but I'll show both in a second. L2 is like second and then two. And then if you calculate, it should give you the mean and standard deviation and all that stuff. So you should get that. That might need to show a different calculator. For the other version, right, this is the other kind. Okay, so this is probably harder because you don't get prompted for the L2 or the second thing. So give this kind of calculator, you go to one variable stats, it just kind of sits there. It's like, okay, I'll do one variable stats. You have to be very specific to tell it. You have to look at L1 and L2. So literally type, yes, one variable stats, but look at L1, comma L2, look at both those spots, and then enter and you'll get the same thing. So this is the mean that you put in. That's what we're looking for. So you'll be the I mean, it's not that bad, but. Okay, did everybody get 2.8? We are not doing standard deviation by hand. You'll never be asked to do that. Don't worry about it. You should hopefully remember that variance is standard deviation what? Squared. If you remember that, you're good. And then we get into these like kind of games, like a lottery. We're gonna try to make a table here, and we're gonna find the mean and standard deviation. What should I do before I forget? Title it. X is money. And there's kind of two ways to think about this problem. Remember, I really wish there was a preferred way. So I can show one way and kind of be done with it, but there's not. So some people, you're paying $1 to play this game, right? And then you're either going to win 500 or nothing, and they just lose your money. And some people will look at it as, I'm just going to forget what I'm paying for the game, and I'm going to subtract 1 at the end. Which means I either win $0 or I win 500. And then at the end, it's going to subtract 1 because I paid $1. Some people prefer to put the -1 like into the outcome. So if I paid $1 and I didn't win, what's my actual overall result? Is -1, right? If I paid $1 and won 500, my actual result is $4.99. let's say pick a digit, a single digit. There's 10 options, you have a 1 out of chance. What's the probability of getting the second digit correct? 10. Probability of getting the third digit correct? 10. So what's the probability of getting all 3 digits correct? 1,000. Well, those are independent events, right? One lottery doesn't affect the next lottery, so if they're independent, you multiply. So the probability I win is 1 over 1,000. That's what's here. Or here, depending on which version you were using. And then what's the probability I don't win? 9,999 out of 1,000. So I want to find the expected value, and I also want to find the standard deviation. And this is where I do have like some advice on which to use. I'm going to type it in the calculator, right? I'm going to find out. I'm going to make the calculator find the mean. If I type in this one, the calculator is going to find the mean, and that's going to be the thing I want, and that's going to write down. If I type in this one, I think a lot of people, it's easier to type in this, see what the calculator says, and write that down, and just forget about the -1. To me, see, I think this is easier like to set up, but this is easier to execute. So just understand, if you're doing this one, put that in the calculator, but then you have to subtract 1. So you can do either. I'm going to do this one just because I don't have to worry about that -1, because I'll probably forget it. Go back to stats. Edit. And I can do this by hand, but I'm doing it here because I want the standard deviation also. I'm not doing the standard deviation by hand. You'll never have to. There's no reason to know that. So I'm going to put -1 and 499. You could put 0 and 500. Just make sure that you remember, if you do that, subtract 1 from the expected value at the end. So this is 999 divided by 1,000, and this is 4. Then I'm going to make it do the work for me. So stat calc. It is only one variable. It's just the amount of money. There is information about that variable in 2 lists. So I have to remember to tell the calculator that, especially if you have the other kind, because it doesn't like pop up and ask you. You got to remember to put L1, L2. And then it calculates. So your mean, your expected value is -0.5. On average, you'll lose 50 cents every time you play it. Expected value, which is the same as the mean, -0.5. And your standard deviation is the 0. It looks like 0. Sigma, something at the bottom. Are we getting what I'm getting? Yes, the calculator's working. Should he play this game? Long run, should he play this game? No, because he's going to, on average, he'll lose 50 cents every time he plays. I understand you can't lose 50 cents playing one. That's not a possible outcome. But over the long run, play it a billion times and average out all your outcomes, you lose on average 50 cents per game. That's like a casino game. Like you got a shot at big money, but the more and more you play, the long run is just going to catch up to you. You're going to lose a little bit of expected value every time, but over the long run, that's up to you. What? Yes. Yes. Yeah, so the 10. Yes. Like 0, 0, 1, 0, 0, 0. Yeah. All right, turn the page. This one's actually a little easier than the one we just did, I think. I'm going to make a harder one in a second. But I want you to try this. It could be that it's tough at this point. I'm not sure. should he play the game is like we were just talking about. Is his expected value positive or negative? Negative, he shouldn't play. Positive, he should. Should be making the chart that looks like that. Start. Fill in the numbers. Careful with this chart. I was counting wrong for a second. Totals are in that box. Like, maybe I should even show you how to see it. I started counting like totals of 6, and I was like 1, 2, 3, 4, 5, 6, 7. And I counted like those, but those are not totals. That's like the first dice and the second. Do the same thing. It didn't feel right. Yeah, yeah. Alright, go to the next page, which is blank. And I want you to figure out that game. You got a spinner, a fair spinner. Equally likely to end in any of these four spots. I want you to tell me the expected value, the standard deviation, and should you run. So if it lands in this quadrant, so yeah, this is kind of a weird game. You're paying $5. If it lands in this quadrant, you owe $5 more. If it lands in this one, they keep the $5 you already paid, and then you just walk away. If it lands in this one, you get your $5 back plus 5 more. $10. Does that make sense? What I'm thinking? Yeah, because that's a dividend pay. This is a horrible game. You spin here, you already paid. They're like, all right, 5 more. Be worth it just for the extra line. Okay, it's more fun to do it or not? Yeah. For what? The friends would make a lot of money. Yes. For standard deviation, probably. Like for me, no. You can just add 11 divided by 49. But standard deviation is bugging. So either way you do it, and I've showed both here. This is like just straight up what happens after you already paid, and then after that you take into account the fact that you paid. So if you put this in the calculator, it came out to 5. 5 minus 5, 0. Or you could have like distributed that 5 through each time. So notice that just this value is 5 less than this one, 5 less than this one, 5 less, 5 less. So you're just doing 5 less in each case instead of all at once again. This one just comes out to 0. So this is what's called a fair game. There's no advantage to either side. In theory, if you played for eternity, you would still be tied. Standard deviation, you got to throw that in the calculator to find out what that is. I got 62.5, no, 7.9. Yeah, sorry. Yeah, that didn't make any sense. And then should you play? That's up to you. Up to you. Yeah, it's probably more fun to play than not, I guess. But. You feel like thumbs up, down, sideways. How do you feel about that? Probably what we did today. Okay, cool. We're good. We'll practice more tomorrow. I'm a what? Like one of those lottery things? Oh, yeah. The expected value of those